Our next session is the panel discussion. So I'd like to move the chairman's role to the Herbert. So Herbert, you have a floor.
Thank you very much, Atsushi. And also thank you very much for all the speakers and presenters, because you were exact in time. So that's not always the case. So we have 45 minutes for discussions and panel discussions. First thing, my name is Herbert Greisberger. I'm the director of the Environmental and Energy and Environmental Agency of Lower Austria. I'm a member of this group. Together with Hannes Warmuth, we represent Austria. Hannes and I had a long and very intense discussion who is going to do the moderation of this session. And as you clearly can see, I lost the discussion, not even close. But I hope we will manage together. He's doing all the background work. Back to the group and our session 3. The idea of the group, and I'm a member of this group since its beginning, is that to come back to our national governments and to give some advice to the IEA, how to collaborate internationally when it comes to R&D, to make R&D more efficient, to make it faster. So our reports in general are focusing on these aspects. And also the core of the panel discussion, how can governments accelerate R&D in secure, affordable, and sustainable critical minerals for the energy transition? I guess from presentations, we're all very much aware that there is an issue here when it comes to minerals and energy transition. We are all aware that the dependency from some countries is very high in this aspect. So we have a lot to discuss, but we should focus this time on R&D and international cooperation. So our first panelists, welcome all 3 panelists, one after the other. Mark Kozdras, he also gave a presentation, he's from Canada, and I ask all 3 panelists to give a statement from 2 to 5 minutes about their ideas how to increase the cooperation in R&D when it comes to minerals. Mark, may I ask you first?
Thanks very much. And indeed, I covered some of the things in the presentation that I gave earlier, and I'll just summarize briefly a little bit about that. One of the focuses of Mission Innovation, which I'm a co-lead for internationally, is to promote the collaboration between countries and within Mission Innovation itself. But we've reached out much, much broader than that. Anyone that wants to get involved can get involved with the work that we're doing. The approach we're using is to accelerate materials discovery through automation and artificial intelligence. And the investment that is needed to develop systems that allow you to robotically or automated investigations and predict how materials will behave is an important facet to that. So the R&D intensity goes right from the basic work, discovery, identifying molecules through simulation and modeling, and then making them in an automated fashion while you in an automated robotic platform, and then characterize them. And that loop, that cycle on the order of minutes and tens of minutes is really what allows us to go from the basic knowledge, the material, right through to a finished material or even a device. We can make these things in these robotic platforms, and we're demonstrating those kinds of things now. So on the part about bridging the gap between basic and applied, we're certainly using these new robotic platforms to do that. That's what I was trying to convey in the presentation earlier. And the infrastructure is an important aspect to this. So when we talk about international aspects and where governments can invest, if we want to do this accelerated materials discovery, we do need both infrastructure in terms of buildings Canada is put in 60 million to build a new facility for accelerated materials discovery that will be done towards the end of 2023. That's one effort that needs to be taken. In Europe, they're investing in infrastructure through the Stories project through ERA. The work that they're doing is to identify infrastructure to be able to solve the kinds of problems that are needed for an energy transition. And those are two examples of intense collaboration that are going to allow us to bridge the gap between basic and applied. Thanks for that.
So thank you very much, Mark. We now come to Kenneth C. Michaels. He's a legal advisor at the IEA. He has been working before at the US Department for Energy. He looks young, but he's the leading author of the report for critical minerals, especially with regard to environmental and social issues, a topic that was already raised in the discussion. Kenneth, may I ask you for a first statement, please?
Thank you, and thanks for the introduction. One of my main activities at the IEA is to support the TCP network. I'm just happy to provide a little bit of background on some of the efforts on the IEA, particularly focused on the technology innovation side. So following the release of the report last year, we got a lot of positive interest and feedback. And in March of this year, our ministers, the IEA ministers, endorsed a new mandate for the IEA that puts the security of critical mineral supplies at the heart of energy security. So they endorsed our work on this topic, and they kind of directed us to expand the work we're doing along the lines of the 6 recommendations that Tae-Yoon presented earlier. The 2 most relevant for this particular discussion being the one on accelerating technology R&D and innovation, and of course on expanding and enhancing international collaboration. So to me, that there's clearly a lot of work going on at the national and regional level in the EU and Canada, the US, Japan, and many other countries. And the question from the IEA's perspective and from my perspective is that are there opportunities to link those efforts at the national level together at the international level? And where really are those areas and where are those opportunities? So thinking beyond the critical minerals topic, the TCP network at the IEA, overseen by the IEA's CERT committee, is our most important tool on international collaboration. And there are many active TCPs on different technologies, renewables, hydrogen, CCUS, et cetera. And these platforms are designed to help countries gain access to shared resources on energy innovation, to influence and set the global innovation agenda, and to help countries identify domestic strengths and gaps and build that innovation capacity and knowledge networks. So there's a lot of reasons for international collaboration. But right now, so then following this new discussion on critical minerals, the Secretariat organized a discussion at the CERT earlier this year to explore whether there's an opportunity for the TCP network to contribute on critical minerals. So overall, there was broad agreement that more collaboration is needed, and the CERT asked the Secretariat to map out the international collaboration activities at the moment on critical minerals technology to help further this discussion. So right now we're working on this mapping exercise. We've spoken with many of the TCPs that are working in this area, and although this is ongoing, I can share a few of those preliminary thoughts. So from what we've seen, many of the existing TCPs already have people and expertise on this topic, specifically on the demand side, when we have many people focused on individual clean energy technologies. However, with the exception of a few, including notably the HEV TCP, we will hear from in a moment, and also PVPS and a couple others, there's not a huge amount of active work on this topic in the existing TCP network. But at the same time, there's near universal agreement that there should be more, and there's great interest in expanding that work and exploring different coordination. So outside the TCPs, with the exception of some level activities at the EU level and among European Union countries, we have not really found many examples of international platforms for collaboration or cooperation on this type of technology. And we would, of course, welcome inputs from you all about whether we've missed any of those. And the mission innovation challenge on materials is one of the ones that we have noticed, but there may be plenty of others that we haven't found yet. So just to finish on what our next steps are at the IEA, we plan to raise this issue for discussion again at the CERT meeting in June. And in advance of that, we are preparing a background note that is based on this mapping exercise and the conversations we've had with TCPs. And we'll also report a summary of the discussions here today to inform that outcome and inform that discussion at CERT. And then at this point, CERT will kind of discuss what could be done across the TCP network to meet the growing research and innovation needs on minerals. So there's a few options on the table, and I don't want to prejudge anything that the CERT will discuss or decide, but just based on our previous discussions, one of the options on the table is a kind of new coordination group that's designed not to be a new permanent institution, but to bring those TCPs together that are interested and at least encourage some exchange. And thinking maybe more towards the long term, countries may consider whether there's a need for a dedicated TCP on this topic, particularly to focus on those areas of technology that aren't covered by the TCPs. The TCPs potentially have quite a lot of expertise on the demand side technologies, but some of the new and emerging recycling technologies and supply side technologies may not have a good fit. So that's one of the things meant to see as a bit more of a long term. We're kind of taking this step by step, and our first discussion is really just to get this snapshot of what's going on. Thank you, and I'm really happy to hear from the other panelists and from everyone else.
Thank you very much. In face of the importance of the topic, it really makes sense to focus more on the IEA on critical minerals. You mentioned the technology collaboration program quite often, and we now come to one of the technology collaboration programs on hybrid and electric vehicle technologies. And Bert Witkamp, he is a senior expert in electric vehicles. He has international experience at senior executive level in industry, in private companies, but also in international associations, also working with the EU Commission. Bert, the floor is yours. I think you have some slides that you want to share with us.
Yes, I will do that. Thank you very much. So in this, the hybrid electric vehicle program, which exists now, I think 25, 30 years approximately, the real focus has been everything to do to promote the transition to electric drive. So everything I'm saying is limited to electric vehicles. And we noticed in discussions in 2017 started that maybe some minerals could become critical, could become a roadblock in the transition to electric vehicles. That is the background that we started the task. So I will start. So what we focused on is mainly to try to identify where would possible risks be. What would be alternatives, and especially focusing on research, what would be research or recommendations for policymakers concerning research? So that's what I will focus on in just a few slides. So now try to share the screen. Is it visible?
Yes, it is.
Okay, so this is just to give an impression on the participants of Task 40, so critical raw materials for electric vehicles. We had 11 participating countries, which is quite a bit because we only have 17 countries in the program. Government agencies, research agencies or institutes, other participants, and we had also the first 3 years of the project quite a few industry players, especially from the mineral side, from the mining side. So what I will show is just, I will start with batteries. This is let's say the summary slide of what, which summarizes the battery demand coming from the different electric vehicle scenarios and split down to the different minerals. I will just take a few points. I compared with several external scenarios. So you recognize the two IEA scenarios which have been mentioned. There's also the EV30 at 30 scenario and some scenarios from the Global Battery Alliance. And these are all expectations for battery requirements. So that is in the top rows. And I don't know, do you see the mouse moving if I move it or not?
Yes, we can see
it. Yeah. So in the top row here, you see the battery demand in 2030 and below several scenarios for nickel. If you look at, for example, the IEA, which is IEA SDS, is a typical scenario where you have a battery demand of about 3,000 gigawatt hours by 2030, which is really dominated by high nickel battery chemistries. And that is leading to an extra nickel demand of about 1.5 million tons for battery only. And that is when we discuss with mining and nickel experts, this is really probably too much extra nickel on top of all the other extra demands, which can be delivered in an environmentally acceptable and economically acceptable way by 2030. If we look at our scenarios, we made a 30% growth as a basic scenario. Last year, we were in line with the IEA scenario, about 3,000. But of course, most of you will be aware of the growth which has been happening over the last 2 years in electric vehicles. It's more close to 100% per year than anything else. So what we do see is that in our view for 2030, the GBA target scenario and the IEA SDS, which might have been viewed as ambitious scenarios 2 years ago, they are probably outdated scenarios. To reach the scenario, you would only need, as from this year on, a 20%, 22% electric vehicle growth per year, from now till 2030, so which is probably much too low. So I will not detail too much on this, but what our conclusion here is nickel will be impossible to meet in the, let's say, in the conventional assumption of high nickel. However, if we look, now I'll just flip to the last slide I want to show. If we look what's really happening in the battery market, we see an enormous growth of LFP chemistries. If we look 2020 compared to 2021 compared to 2020, the battery output on LFP base is 3 times higher than 2020, and the market share has gone up from 18 to 30% per year. Why? Because they are more stable batteries, they're cheaper, longer lifetime, lower footprint, etc., etc. But most importantly, they have become the performance of LFP batteries has become good enough for almost all electric vehicles. I'll just show a little bit. No, not this one. And I think the proof of that pudding can be seen if you look at Tesla, which last year had all its Model 3 and Model Y made in China, the standard range based on LFP batteries. Presumably, what I heard and understood is in Q1 of this year, 50% of all Tesla vehicles was based on LFP batteries. So the resurgence in LFP chemistry in performance is such that in our view, it will by far dominate the electric vehicle battery market in only a few years' time. And this is also what is needed, otherwise the growth will not, we cannot continue. So that is one of the main conclusions when we look at batteries. In our view, therefore, I will skip the sharing. Yeah. In our view, therefore, both nickel and cobalt will not be critical for electric vehicles anymore. And certainly the research recommendation there is to make this transition as quickly as possible, because we will need nickel for many other applications. And if we look at electric vehicles and we focus on batteries, the only really critical material which we see at this moment is lithium. And again, there we have maybe some of you have followed the news also in China from CATL, the world's largest battery manufacturer, who has announced to come by next year, I believe already, the first production-ready batteries, partly based on sodium replacing lithium. And so what we really need, because lithium is at this moment the material which is most difficult to replace in electric vehicles by any other materials. And that is what we should focus research on. So both replacing lithium, but also, for example, research on getting recovery lithium from brines, from geothermal plants, for example, or even things like lithium from seawater. But replacing lithium is really the biggest challenge and the biggest reward, because if we would be able to do this, it would make electric vehicle batteries geopolitically independent. And I think especially this year, that's even more important than it already was before. So I would like to, sorry, it has been quite a long monologue. I would like to stop on this, and maybe later I can come back on two other important areas where we looked at. That is, of course, rare earth used for electric vehicles. And also, I'd like to make some comments later on the impact of electric vehicles on the platinum group metal market, where, of course, the impact is very positive. Yeah. Thank you for your patience. Yeah.
Thank you very much, Bert. Just one word to all the participants. You have two options to come into the discussion. One is to write a comment, and the second one in the chat. And the second one is to raise your hand, and Hannes Wammet will give you the microphone, so to say, so you can present your statement personally. May I come back to you, Kenneth? I think it was Birte who came up with the comment, can all interested countries collaborate in all R&D aspects on critical minerals on the, I guess, on the IEA level? And are there any concerns on IPR or issues related to critical infrastructure?
Well, just to speak from the perspective of the TCP network at the IEA, which encompasses both the HEV and Task 40, which Bert organizes, but also several other activities and other TCPs. In general, the TCP network and each individual TCP is open to any country. We have countries from around the world participating in many different TCPs, not just from the IEA, but also from our broader group of what we call association members, which includes a kind of target group of countries that the IEA engages more closely with, like Brazil, China, India, and others. But we also have participants from beyond that network. And just to say that the TCP network is underpinned, each TCP is underpinned by a legally binding agreement called an implementing agreement that does have provisions for intellectual property that can be taken into account. Over the past history of many decades, there have not been a huge number of intellectual property type disputes. So just to say that the system works reasonably well, and we haven't seen this be a major obstacle to collaboration, and there are some mechanisms to kind of allow that.
A second question here is for Batsushi, especially with the background in Austria, with the gas dependency from Russia in these days and months, and the problem we see here. He was asking, will strategic reserve in each country reduce the supply risk that we actually have, or that we can see, and some of you of the presenters put your finger on this issue? What do you think about that? Is that a relevant strategy? should we recommend this to the IEA member states? Not so much to R&D, but yes, Kenneth?
I can say a couple brief words on this, just that there are some ongoing discussions at the IEA on this exact topic. So one of the things in the ministerial mandates for 2022 that were approved for the IEA is they've charged the IEA with launching a new, what we call voluntary critical minerals security program, which may include coordination on stockpiles. Several countries do already have some version of a stockpile, including the United States, Japan, and other countries. But this is something that will require a lot more thinking through, because obviously there are technical challenges. They're very different markets, and there's a lot of considerations that are relevant there. And just to say that it is something countries are considering for the purposes of energy transitions, and it does probably have a role to play. But just preliminarily speaking, unlike the oil markets where we have relatively fungible materials in a very transparent market, it's not likely going to be, it's not an end-all solution. It's not a silver bullet. It may have a role to play, and it's something that the IEA countries will be thinking through.
Thanks. Any other comments on these two questions?
Yeah, I want to make one remark that I think it's important to look across different applications of the potentially critical minerals, and when looking at what is priority. And for example, when you talk about rare earths, currently most electric vehicles, they use rare earths for the electric motors, and that is because it's a little bit more efficient, it's a little bit lighter. But if we continue to do that, then by 2030, you would need the current total output of the rare earths needed for permanent magnets for electric vehicles, and probably faster than 2030. But in reality, they're not essential. Rare earths, electric motor, permanent magnets, are not essential for electric vehicles. There are quite a few alternatives. The first Tesla cars didn't have them, for example. So this is for me an example where we really should, and both from a research point of view, but also from a policy point of view, focus on getting rare earth permanent magnets out of electric vehicles. Because we need them much more in, for example, offshore wind turbines. And so this is somewhere where also between different sectors and application areas, that there should be some sort of a coordination. And that can only be at governmental levels.
Mark?
Yeah, and what Bert is saying is quite important. One of the things that I've been working on is the alternatives to the permanent magnet motors. And there's other aspects of motors that we have to be concerned about. The one thing that I noticed in the executive summary of the critical minerals report, the one that's referred to earlier, copper. The need for copper in everything. And one project that I mentioned briefly was the use of aluminum conductors as an alternative to copper. Not only is the cost of that much lower, the weight compared to copper on a transportation application is critical as well. So changing it from permanent magnet motors so that we can reduce the reliance on that, but also changing potentially to new materials for the conductors like aluminum. And one of the projects I mentioned was that we're working on aluminum scandium wire, where we're getting the strength we need, but we're getting the electrical conductivity as high as we can in aluminum. And we're working on technologies to actually enhance the conductivity of the aluminum to get closer to copper. So those technologies are extremely important to be able to succeed in getting the kind of volumes of vehicles that we want out in time. So I thought I'd throw that in as well.
Okay. Yeah.
I just wanted to add one part of thinking about the elements of the supply side technology at the same time or in parallel. Because I think while we certainly agree about the need for new substitutes and the existence of many substitutes, like when we think about electric cars, about not using magnets and also moving to LFP chemistries and other alternative chemistries, we've also have to take account of the existing capacity of battery manufacturing projects and the existing kind of manufacturing capacities that are being put online now and that presumably have long lives. So I think from our perspective, these new technologies are really critical, and we do need to invest and support the uptake of them as quickly as possible. But we also have to recognize that there will be demand concerns that we can start to anticipate, and that the mining industry and the recycling industry are not yet prepared to respond to. So when we think about the medium term, switching to alternative technologies is important and something we should support as much as possible, but we also have to make sure that we don't lose sight of the potential challenges that we might run into on the supply side, particularly if those transitions don't take place as quickly as expected or hoped.
But Kenneth, when you say you have to invest, do you mean it's in the public domain, or you mean the industry that has to invest? Mark was first.
I think the answer to that is both, a little bit, and I assume the answer was both. What I wanted to look at is, of course, there's announcements of battery plants, and I'm more familiar with the ones in North America. Battery plants, they're going to lithium. Bert is right. Lithium iron phosphate, it's a robust technology, and they need some certainty in being able to put in a robust solution as fast as possible. Those demands are going to be extreme. It's absolutely correct. But Bert also mentioned the alternative metals like the sodium, and I've seen some really good information on zinc. So those technologies are there. They just need to be developed so that we can avoid, as we ramp, we can avoid and transition in a way that allows us to react to that new increasing demand. And so I think the focus, and I mentioned Big Map, the project Battery 2030 within Horizon 2020, that's working diligently on alternate technologies, but they're putting in place an autonomous automated system to develop these kinds of technologies. And we really need to pay attention to that and enhance that collaboration so that we can address Bert's needs down in time. That's all.
Yeah, I want to add to that two things. One is that most of the equipment or the capacity being built at this moment in production of batteries, for example, they are very flexible. You might need to have some small adaptation, but they're extremely flexible to what kind of chemistry. Even replacing lithium by sodium, that can be done on the same line, even going to solid state. So there's a very high flexibility there. The second thing is, indeed, when we talk about the switch to LFP, that is happening today. And again, the Chinese, they understand it and they are leading. And in Europe, we're still working on optimization of high nickel chemistries, but that is yesterday's technology for electric vehicles. So, and that is the switch that we have to make, that when we talk about research, we should work on the things who are at the front, where things are happening, and not what has happened yesterday. And that is, I think, the paradigm shift that we have to make, certainly in Europe. I don't want to judge other parts, but it is certainly that we really need to change the shift of where we put the research on. Industry will take care of the existing technologies. They will make that work. And the other thing is that the transition now is going so rapidly. And if I look at the data, I would say the IEA SDS scenario, we will probably have twice the amount of electric vehicles by 2030 than is projected in that scenario. And even if we don't believe it, because I've been calling things since 2014, but and every time, it's happening, but it's always, it happens faster than everybody thought. No, prepare ourselves. So even if we don't believe the scenario, and make the scenario and prepare ourselves. And that is also what we really should learn. Yeah. Maybe one last mark about platinum group metals. Of course, when you look, because that is a very hot topic also geopolitically, and there are many applications needing those materials, but 80% of the net demand of palladium and rhodium goes in autocatalysts. 80% and 50% of the net demand of platinum goes in autocatalysts. So the sooner we get rid of those, the sooner we will diminish the problem of the platinum group metals. And of course, there is also, so that is the net demand. But of course, with a backlog of 15 to 20 years, you get all the spent catalysts where you, in addition to not using platinum group metals for cars anymore, you get a lot of materials from recycling. And so that's why it's also so important to focus on those scenarios and for the transition, to take that into account.
Kenneth?
Yeah, I just wanted to make a brief point. Obviously, we released our minerals report last May, and in the intervening time, we've also had this big push on the IEA's net zero roadmap, and we have updated most of our demand and supply projections for the World Energy Outlook 2021. And just wanted to note that the point taken of the speed of the uptake of electric vehicles, but in the IEA's net zero 2050 scenario, we have a much, much higher uptake of electric vehicles than we did in the STS. So that's just to note that it's encouraging to see that number creeping up and closer to in line with what we are hoping to see on a truly net zero pathway. And in any case, we'll be updating these projections again for World Energy Outlook 2022.
Thank you. We have only 3 minutes left, so we should also keep the high standards of our colleagues, moderator and presenters. So I would ask you for a last round, each of you. Just imagine that you're sitting on a table with the representatives from the US and Canada, the European Union and Japan, and to give them some advice on this aspect. What would you say they should do when it comes to R&D, to international cooperation in R&D, focusing on critical minerals? Who wants to be first? Mark, please.
Okay. One of the things that I was going to comment on was what Kenneth said earlier and his discussion about coordination group. I think it's really important. I was one of the people in Canada that suggested that that be a strong thing to send up to the CERT so that they see what's going on. I can tell you I spent 10 years on the TCP Advanced Materials for Transportation. The interaction with HEV, the interaction with other TCPs, it's hard to prioritize. And so we need a coordination group, especially now, especially because of the drive for electrification and the importance of critical minerals. That has to be brought together. And so if I sat and said one thing, I'd support that so strongly moving forward. So that's the message I'd like to send.
Thank you very much. Kenneth, it's up to you.
Well, just to add on that, I mean, that's probably largely what my point might have been. So thank you for that strong support, Mark. But the other way I might put this is that I think governments around the world are doing a lot and really recognize how important this is at the national level, and that much is very clear. But when we look at the kind of collaboration landscape, we haven't yet ramped up to the level of interchange and exchange between countries that we do see on, say, wind and solar panels and things like that. And I think there's a lot of value in that. And I think that we all need to think about what architecture we need to enable that and to facilitate that.
Thank you. Bert?
Yeah, I would say a paradigm shift on how, I'm talking about electric vehicles, how electric vehicles in 2030 will look like. They will not have critical minerals anymore. They will use half the energy of today's electric vehicles. And the batteries they will use, they will last decades. So that is the paradigm shift where we have to work to. And we have to focus on the research needed to go there as soon as possible. because that is written almost in stone. We will go that way because that is the thing, the way science is developing. But we can help it a lot, and that is what we also need, because we need to have the transitions as quickly as possible.
So thank you very much for your input and the discussion. Very, very interesting discussion. In the EGRD, we have very difficult tasks, easy ones and more difficult ones. Bert always gets the easy one to make the start. But to be fair, the more balanced, she also gets the very difficult one to make the closing comments. What is really is a challenge.
Yeah, thank you very much. It has been a pleasure to listen to all the good presentation, discussion and Q&A, and not least the panel discussion here in the end. The demand for critical minerals definitely is running ahead of supply, but as was emphasized by the IEA resources, it's not a quantitative problem, it's a qualitative problem. There's need for innovation along the whole value chain from mining to the end use in different renewable energy technologies. Mark Kozdras highlighted the need to reduce, replace, and enable, and also explained with good examples how to use robotic automation in accelerating new materials. Robert Marley highlighted that superconducting generator design actually use less critical mineral than conventional wind turbine design. So a very good example of how to reduce the critical minerals. Later, the Japanese presentation explained in detail the separation technology. And also the EU Commission gave us a list of important R&D projects. Then the EU Commission representative also said that we should be aware of the risk of changing one energy dependence with another, referring to the dependence on all the work being done by China in processing, but they are also very dominant in producing permanent magnets. So the idea is to create more robust supply chains so that we do not experience disruption in these when we go for energy transition. The American presentation highlighted the year-long work on this topic and also the enormous public investment in researching the critical materials and minerals, not least within rare earth elements. Now, I want to not to say so much more, but international collaboration is important, and the TCP are open to any country around the world, not only the IEA member countries, but also associated countries like Brazil, China, India, and more even so. And the scheme works pretty well. So there's no concern regarding science and science collaborating on these issues. This can be managed in a global context. We will draft the summary report and send it out for your comments. I, together with the Vice Chair and Hannes Wartmund, will synthesize the key messages from this webinar and broadcast them to Austrian Innovation Week next week. I want to thank everybody for participating, for listening in, and with these words, I wish you a very good weekend. Thank you very much.